A common way of representing the composition of a system is by using percentages. So for instance, if we have the molecule CH4, there are 5 atoms in each molecule. One of those atoms is carbon, and 4 of those atoms are hydrogen. Therefore, 1 out of 5, or 20%, of the atoms are carbon, and 4 out of 5, or 80%, of the atoms are hydrogen. This would be an example of percent composition by atoms or moles, so molar percent composition. What we find is that since we cannot measure the number of atoms or the number of moles of a particular substance except by looking at the mass or some other property that is measurable, it will be important for us to be able to express the composition of a particular molecule in terms of mass percent. And so we are going to look at the concept of mass percent in this video. A percentage is always expressed in terms of part of the system divided by the whole system. If we're looking at mass percent, then we want the mass of part of the system, the part that we're talking about, divided by the mass of the whole system. So if we look at our example of CH4, we can compute that the mass, the molar mass of the whole system is 12.011 grams per mole of carbon, because we have 1 carbon, plus 4 times 1.008 grams per mole of hydrogen, because we have 4 hydrogens. And so the molar mass of the whole system, CH4, is 16.04 grams per mole of CH4. So if I want to know the mass percent of carbon, then I need to take the mass of carbon in the whole thing, which is 12.011 grams per mole, divided by the mass of the whole thing, which is 16.04 grams per mole, and then of course times 100% to get it into percents from fractions. So 12.011 divided by 16.04 is equal to 0.749, or 74.9%. So that's the mass percent of carbon in CH4. If I want the mass percent of hydrogen, I need to take the mass of hydrogen in the molecule, which is 4 times 1.008 grams per mole, because there are 4 hydrogens, divided by the mass of the whole thing, which is 16.04 grams per mole, and then times 100% to get it into percents from fractions. And that gives me 4 times 1.008 divided by 16.04 is 25.1% hydrogen. So the thing that you will notice about this is that the percentages have to add up to 100%. So if I add 74.9 and 25.1, I get 100%. In addition, when we are calculating percentages, we have to make sure that both of the numbers in the numerator and the denominator, the number that we use for the part of the system and the number that we use for the whole system, have to be in the same units, because a percentage is a unitless number. And that's what makes percentages so powerful in terms of expressing the composition of a system. Now it's your turn. Figure out what the mass percent of carbon and the mass percent of oxygen are in CO2. If you work this out correctly, you will find that CO2 is 27.3% carbon and 72.7% oxygen.